Hi, and welcome to 6.5 Algebra 2 Notes. We are going to look at the properties of logarithms, and we'll find that those properties of logarithms relate a little bit to the properties of exponents and how we actually deal with them. So here's our basic properties. The product property says that if you have taking the log of two numbers being multiplied together, like the log base b of m times n, basically when you break that apart, it'd be log base b of m plus log base b of n. Similar to when you had exponents, if two things were being multiplied together, you added the exponents. When you are multiplying the log of two things, you break it apart and you add the two pieces together. If you are looking at the quotient property, which basically means you are taking the log of two things being divided, log base b of m divided by n, you break it apart and you are subtracting those logs. Much like when you divided with exponents, you subtracted those exponents. When you have log base b of m divided by n, you can break it apart and subtract both of those logs. The power property basically says that if you have an exponent, when you rewrite it, you can change the form and you can basically take that exponent and put it into the front, so you'd have log base b of m to the n. Take that n, put it out in front, and you multiply it times log base b of m. So let's go ahead and just look at a couple of examples of how you can use these properties. So up here I have log base 4 of 8. Okay, essentially all we are doing is writing the same log in different ways, equivalent ways. You could put any one of these three values up here into your calculator and you would get the same answer. All we're doing today is looking at different ways to manipulate and write these logs so that at some point if you need to write them in a different way to solve a problem, in a story problem or something like that, that you understand these properties on how you can manipulate these numbers. So if we had log base 4 of 8, I'm thinking, okay, I can have a factor pair of 8 is 2 times 4. So now I have log base 4 of 2 times 4. If I have two things being multiplied together, I can break that apart and call it log base 4 of 2 plus log base 4 of 4. Again, we are not going to calculate these out to decimal values or anything for right now. Right now we're just looking at how we can change the form and make them look a little bit different, but still equivalent. If we had log base 5 of 10, that would be, I'm thinking, okay, a factor pair of 10 would be log base 5 of 2 times 5. If I have these two numbers being multiplied together, 2 times 5, means I can break it apart into log base 5 of 2 plus log base 5 of 5. Okay, same idea here, just moving down to a couple of other examples. Log base 2 of 21 would mean we'd have log base 2, we could call that 3 times 7. 3 times 7 is 21. If they are multiplied together, log base 2 of 3 times 7, we could rewrite that as log base 2 of 3 plus log base 2 of 7. We're just taking that log of the two things being multiplied together, breaking it apart, and adding them together. The next two questions are division questions, so we're going to go to that quotient rule, where if you have log base 7 of, or excuse me, log base 5 of 3/7, that's essentially log base 5 of 3 divided by 7. So if we were going to break it apart, division means that we would subtract. So we would have log base 5 of 3 minus log base 5 of 7. Similarly, down here on the next one, log base 4 of 5/8 could be rewritten as log base 4 of 5 minus log base 4 of 8. Okay, so that's practicing that quotient property. And then here we're going to have that power property where we have it taken to a power, like 5 squared. And if you have that, basically you are going to take the exponent and move it to the front. So log base 3 of 5 squared would be would be, erase that, hang on, we have to move that 2 out into the front, would be 2 times log base 3 of 5. Okay, same idea, log base 6 of 7 to the third power. Take that exponent, move it to the front, 3 times the log base 6 of 7. So we're going to be using these types of properties in the next couple of days to solve different equations, solve different problems. So that's the basic idea of how those properties work. So now what they've done is they have given us values for log base 2 of 3 and log base 2 of 7. Which means if we look at how the problems are written, we are kind of basically asking ourselves, are we going to add those numbers together? Are we going to subtract them? Are we going to multiply by a power or anything like that? So if I have log base 2 of 3/7, again 3/7 is 3 divided by 7, which means we would have log base 2 of 3 minus log base 2 of 7. Well, in the directions, it gives us the value of log base 2 of 3 is 1.585 minus, and it also gives us the value of log base 2 of 7, which is 2.807. And when you go and actually subtract them, you get negative 1.222. Okay, so looking at our next one here, we have log base 2 of 21 would be like log base 2 of 3 times 7. We just took 21 and rewrote it as 3 times 7 because we know in the directions it gave us the decimal values for 3 and 7. Well, if we have log base 2 of 3 times 7, that means we would have log base 2 of 3 plus log base 2 of 7. Which means we'd have if we put in the numbers they gave us, 1.585 plus 2.807, which would be 4.392. Okay, and looking at the next one, if we had log base 2 of 49, okay, well, we want to think about how we can write 49. So it's written in terms of either 3 and or 7. Well, 3 doesn't even go into 49, so we need to think about it as 7. Two thought processes of how you could do it. You could either think one way, okay, so method 1, and you can see how this actually works, is you could say it's log base 2 of 7 times 7. Okay, so that would be log base 2 of 7 plus log base 2 of 7, which is 2.807 plus 2.807, which is 5.614. Okay. Method 2 would be you would change that 49 into 7 squared. So you would have log base 2 of 7 squared. Well, then you would just take that exponent that's the 2, put it out in front, and you would have 2 times log base 2 of 7, or 2 times 2.807, which is still the same answer, 5.614. I think the method 2 in blue is probably a little bit easier, but either way will work. Okay, so here's just, a couple of more examples of how you can do that with decimal values. Okay, it tells us log base 5 is 0.898 and log base 6 of 8 is 1.161. Well, if we have 5 divided by 8, that means we're going to take log base 6 of 5. We're going to subtract log base 6 of 8, which is going to be 0.898 minus 1.161, which is negative 0.263. Okay, log base 6 of 40, that's essentially like, instead of 40, we're going to call that 8 times 5. Okay, so we'd have, if they are being multiplied, 8 times 5, we'd have log base 6 of 8 plus log base 6 of 5. So we are going to add 0.898 plus 1.161, and we get 2.059. All right, down here, log base 6 of 64. Okay, so I'm thinking I either need to have it in terms of 8 and or 5. Well, 5 doesn't go into 64, but I do know that 8 squared is 64. So I could have this, think of it as log base 6 of 8 squared. If we have an exponent, we bring it out into the front. We'd have 2 times log base 6 of 8, or 2 times 1.161, which is 2.322. If we're looking at log base 6 of 125, that would be like log base 6. Well, we're not going to put it in terms of 8. We're thinking in 5, which is 5 cubed is 125. That exponent's going to come out into the front. So we'd have 3 times log base 6 of 5, or 3 times 0.898, which is 2.695. Okay, this time they don't actually give us any values for decimal values or anything like that, and it actually has variables in the original problem that you're starting with. Okay, so if we have log of 10 times x, okay, and we're not breaking down 10 into 5 times 2 or anything because there's not any decimal values that we know that we're going to use to go along with that. So we're just thinking, okay, I have 10 times x. Well, that means it's multiplication. So that means I'm going to break it apart and say log of 10 plus log of x. When you go to do, I believe this problem is actually a homework problem, they want you to simplify log of 10. Log base 10 of 10 is just 1. And then the log of x can stay as the log of x. If you're looking at the second one, it's a natural log, but it follows the same rules. The properties are the same for natural logs as they are for logs. One thing that you should note about this is the natural log of 2x to the 6th is the natural log of 2 times x to the 6th. The 6 only applies to the x. It doesn't apply to the 2 also. So the first thing you'd want to do is think of it as multiplication and break it apart into the natural log of 2 plus the natural log of x to the 6th. At that point, our natural log of 2, that's broken apart as much as we can. However, the natural log of x to the 6th still has that exponent on it, which means you are going to need to move that 6 to the front. So you have the natural log of 2. That stays exactly the same. Plus, you're going to take that 6 and move it out in front and have 6 times the natural log of x. And there's no more simplifying or breaking anything apart. All you're doing is taking a nice condensed little problem and breaking it apart as much as you possibly can. On the next question, we have the natural log of 5x to the 7th divided by y. Okay, first thing I'm thinking is, all right, I've got division, so I need to subtract. So I'm going to take the natural log of 5x to the 7th minus the natural log of y. Okay, so that natural log of y is all good. Okay, there's nothing else that we can do to that. I'm going to highlight that there. However, the natural log of 5x to the 7th has a couple of things. First of all, it has multiplication because there's 5 times x to the 7th. So let's go ahead and rewrite that. So we'd have the natural log of 5 plus the natural log of x to the 7th. That's just taking and breaking those two pieces apart, minus the natural log of y. That's all good. There's nothing that we need to change with that. Now our first term, the natural log of 5, is good. We don't need to change that anymore. The middle term, the natural log of x to the 7th, has an exponent, which means we need to move that exponent into the front of that term. So we'd have the natural log of 5 plus 7 times the natural log of x minus the natural log of y. And that is as simple as it can get. There's nothing more that we can break apart. There's no more exponents that we haven't dealt with. Okay, so this is where we're going the opposite direction, meaning that we need to condense. Okay, so it's already broken apart. It's already given to us as an expanded problem. Now what we need to do is actually condense it. So if we look at our problem here, it's an addition problem, which means if we're thinking backwards in our head, if we have two logs that are being added together, if we're going to condense them back together, that means we're going to have multiplication. So if we're going to go backwards here and put things back together, it's kind of like taking things apart and then putting things back together. Okay, that's basically going backwards, saying the log base 2 of 3 times 8. Okay, we took that, it was an addition, broke apart, they have the same base, everything, so when you put them back together, that addition implies when you put them back together, you're going to multiply. So you'd have log base 2 of 24. It's all put back together. There's no coefficient out in front that would be an exponent, anything like that. On question number 10, okay. Okay, so on question number 10, it looks like we should notice a couple of things. One is that we have subtraction, so we know there's going to be some division. The second thing we should notice is that there's a coefficient of 2 in front of the log base 5 of 5. The first thing we want to deal with is that the coefficient of 2 and get rid of that before we do the division. So we would have log base 5 of 4 minus, we're just going to take that coefficient of 2 and make it our exponent, log base 5 of 5 squared, which is the same thing as log base 5 of 4 minus log base 5 of 25.
I have a gift for you.
So now what I notice is I have log base 5 of 4 minus log base 5 of 25, which means that subtraction tells me I'm going to divide those two, which means I would have log base 5 of 4 over 25. Okay, so we've got quite a few things going on in this one. First thing we want to take care of is that coefficient of 3 in front of the natural log of 6x, because we don't want to have a coefficient in front of there. We want to get rid of that first. So the first thing I'm going to do is I would have the natural log of 6x. And again, since it was out in front of the natural log of 6x, that means that is being applied to both the 6 and the x, plus the natural log of 4 times y. We're going to go one step at a time here. So if you have the natural log of 6x to the third, that third power is being applied to both the 6 and the x. So you'd have the natural log of 216, because 6 to the third power is 216 x to the third. So this, 6x to the third, when I applied that third power to both of them, gave me 216 x to the third, plus the natural log of 4 times y. Okay, so the next thing, again, I'm trying to put everything back together. So I have the natural log of 216 x to the third plus the natural log of 4y. That plus tells me that I'm going to multiply 216 x to the third times 4y. So when I'm putting things back together, our brains need to go a little bit in the opposite direction here. So I'd have the natural log 216 times 4 is 864 x to the third y. So let's just look at a couple more examples of expanding and condensing. If we had log base 6 of 3x to the fourth, okay, again, this time we are expanding it. It is already condensed, so we're expanding it back out. First thing I would say is, okay, I've got multiplication, so I would have log base 6 of 3 plus log base 6 of x to the fourth. That log base 6 of 3 is fine, but the second term, log base 6 of x to the fourth, has an exponent that needs to be brought down in front. So we'd have log base 6 of 3 plus 4 log base 6 of x. Once we've have that exponent taken care of, then we can be done. On the second one, we have the natural log of 5 divided by 12x, which means we're going to take, if it's division, we're going to take the natural log of 5 minus the natural log of 12x. That 12 and the x are being multiplied together, so we're going to have the natural log of 5 minus the natural log of 12 plus the natural log of x. And since we are subtracting all of the natural log of 12 and the natural log of x, we should put those in parentheses. Or we could distribute the negative and say the natural log of 5 minus the natural log of 12. If we distribute that negative to both parts, it'd be minus the natural log of x. On the bottom two, we are putting things back together. We are condensing. We have the log of x minus the log of 9. There's no coefficients or anything that we need to make into exponents. It's just subtraction. So we'd have the log. If it's subtraction, that means we're dividing, of x divided by 9. On question number 8, we kind of need to look at each term. Okay, the natural log of 4, there's no coefficient to make into an exponent. However, if we look at our second term, 3 times the natural log of 3, we do need to actually take care of that. So I'm just going to rewrite everything else. The natural log of 4 plus, I'm going to take that coefficient and make it back into my exponent, times the natural log of 3 to the third power minus the natural log of 12. Okay, well, we know what the natural log, or excuse me, we know what 3 to the third power is. So I'm going to rewrite that. Go on every step here. The natural log of 4 plus the natural log 3 to the third is 27 minus the natural log of 12. Okay, so if I look at my first two terms, I'm just going left to right here. I have the natural log of 4 plus the natural log of 27. If they are being added together, that means we multiply. So we'd have the natural log of 4 times 27, which is 108, minus the natural log of 12. And finally, that's subtraction, which means we would actually be dividing the natural log of 108 divided by 12, or the natural log of 9.